In this episode, I'm going to talk about inversion. Consider a seismic or outcrop section like this. So the question that comes to mind is, what's the sequence of deformation? What happened before what? So I'm going to walk you through a simple example of a model or sequence of deformation that could actually lead to sections like this. An example of inversion. So imagine during the stage one, this is what it looked like. What are your observations? Both blocks seem to have moved apart from each other. So we see, first of all, we see a vertical offset between the hanging wall as a strata to your left, from the footwall as a strata to your right across the faults. So we see, some expression of, vertical offset, which we call through. Secondly, you also observe that the thicknesses have changed from what you have on the footwall to the hanging wall. In other words, we had extension, both blocks being pulled away from each other. There is vertical offset, the block on the right, on the left, on the hanging wall, being moved vertically down relative to the block on the footwall. That's on the right. There is thickness change. We see that it's much thicker on the rollover structure on the hanging wall, which tells us that there's some evidence of growth. In other words, the faulting happened at the same time that this stratigraphic unit was being deposited. During the second stage, we note some form of reduction in the offset that we had initially, somewhere here where you had the footwall and the hanging one being separated. We see that distance has been closed up. So what this suggests is that we have currently have some form of push from the left to the right. So you see the hanging wall moved vertically upwards, and thereby reducing that offset it had from the footwall. You also note increased curvature of the rollover anticline on the hanging wall. That tells us there's some kind of force pushing it upwards, and because of space constraints, it's hard to make that increased curvature in its the curved angle of this structure on the hanging wall. At stage 3, we have increased vertical motion. During this time, you actually lose sense of the initial throw direction, and that's because the hanging wall strata had continually moved vertically upward, so you can't really tell that this was even an originally normal fault except by looking at the thickness relationships. So by this time, this structure is inverted. You also note the increased curvature of the the hanging wall strata. Note that you have self juxtaposition across the faults between the footwall and the hanging wall package. That tells you a lot about what this stratigraphic unit had passed through, starting from an originally normal fault system where you had through package being thicker on the hanging wall to your left and thinner on the footwall to your right, and then what was originally a normal fault system now became inverted, and the system started moving towards the right, and where it's now had to make a more of a tighter anticlinal structure on the hanging wall, and that whole configuration that kind of generated what we're seeing today. Finally, you have some relief and some kind of stress relief, and you have indications of extension at the crestal part of the anticlinal structure. So this is the final configuration as we currently have it today. So this is just a summary of how these processes happen and how it goes from an originally extensional domain with normal faulting, with growth structures, and how tectonic events can actually flip, and what was originally a normal normal fault system can get inverted, and now you have it flip to reverse fault. So in this very case, we started off with the blue faults. That's the normal faults, right? So this is stage one, and then you had growth faulting and everything that came with it, and then eventually we had a flip, and then you now had some kind of compression from both sides, and that was when this reverse faulting cycle came up. That's the red arrows. And that was also the time that he had increased curvatures for this, strata on the footwall, and also increased curvature for the strata on the hanging wall. And at the same time, you also had reduced offset. So what we had as a positive offset with the package from the left on the hanging wall being moved downwards had now inverted, and it reduces to zero, and eventually you have a flip. So what was now all the way down to the left had become currently all the way up as we see it today. So thank you very much. I hope this was helpful for those who asked questions. Thank you very much.